Morning everyone. Okay, so let's talk about the data stream changes that we've made inside of the example here, the TinyDash. This is also going to be in all of our other products like the all drive controllers, the S7 generic build where it allows you to do custom CAN transmit and receive. A few of these requests have come from dealers. We'd like to kind of listen to the dealers and update it, and some of the requests were really cool, but some of the stuff on here is really useful to show off what you can actually do with some of these products to make really cool packages and really cool functions, not just for cars but for other aspects. So let's go over that. So let's head to the data stream area and see some of the stuff that's changed. In different products you'll have different options, like you might have a CAN 0 and CAN 1 option in here because of different amounts of CAN bus, but the TinyDash has literally just got the single CAN bus. So it makes it easy just to showcase this video, etc. So some of the stuff that's changed, we've done a video on all this stuff before, the generic CAN receive, which is on our YouTube page, Syvecs help. So what we've done now is we've added in a multiplexed indexed. So what a multiplex frame is instead of just sending an arbitrary ID with a frame of data, the multiplex value allows you to kind of compound layers on an existing arbitrary ID to have multiple amounts of data in one identifier or arbitrary ID, however you want to call it. So what I'm going to do is I'm going to show you how you go about doing the receive aspect of this at the moment. So what I'm going to do, just going to enable that, and the thing that I'm just going to pick up is just going to be RPM, and I'm just going to punch this in the 105 arbitrary ID, and I'm just going to leave it all there for the minute. The value that I'm sending is little endian, and the start bit of that is 16. So, and the length is 16. So I'm just going to go over to a CAN transmission tool that I have. So I'm just going to transmit that frame now. So I'm sending 105. I'm sending the values in the second and third bytes, and because I always start from 0, the first byte is 0, then 1, 2, 3. So I'm actually sending these in the second and third byte, and just sending 2222. Okay, so what that will actually do is we're going to here, we're just going to program that, and we actually should see now that the RPM is picking up a value. Okay, so what I'm going to do is just leave that there so you can see that the generic receiver is picking up that value and is scaling it in based on the scaling and the offset which I've set in here, which I haven't set. They're just generic values, but you can set them however you want. So what you can now do, so let's say you've got a multiplexed frame, so you're basically transmitting, so let's say a device is transmitting a CAN message which contains multiplex frames. So basically what that would mean is in the arbitrary ID here would stay 105, but you'd have different layers. So let me just set that up so you can see how that would work. If I just copy this and paste it and then punch in here, say 10, and then 20, and then we'll transmit that. And then, so what that will mean now is basically the same arbitrary ID is being sent, but you've got the compounded multiplex layers of the first byte, which is generally how it is with multiplex frames. So you've got one frame that's sending a 0, one is at 10, and one is at 20. So what I'm going to do is I'm just going to change the values of these just so they are slightly different, so you can see that they're being picked up differently. So they're being transmitted. Now what I'm going to then do is, so at the moment now what it's doing is it's picking up the last message which was being obviously transmitted, which is going to be this one here, the 05. So I'm now going to tell the system on here to look at the multiplex frame of looking at the 10 hex. So the values in here are 100 hex to start with. They're the default values. If you press F1, it will tell you here that the value of 100 hex is ignored, so that it's not using the multiplex index. So what I'm actually going to do is I'm now going to basically say, okay, so I'm only interested in picking up the, say, the first layer at the 10. So I'm going to change that, and then what that will now do is the receive function will only be looking at the values in this frame of data, okay, where the multiplex first byte is at 10. So then it'll be looking at the 10 and 10 there. So let's say we've got it, so it's picking up 4112. We can change the CAN structure on just that layer, and now you'll see that the received value has changed. So that's one aspect of the new changes which we've done to the generic receive to have the multiplex layer. So let's then move on to the other layers. So just to reiterate, you've got a list of loads of predefined CAN structures in here, which you can set up to receive automatically. And then the next stage. So what we've now done in the generic CAN transmit is we've also added a multiplexed function in there. So generally speaking, as we spoke about before, the multiplex frames are generally sent in the multiplex bytes, are generally sent in the byte 0 point. So what we're going to do, what this basically allows you to do now, before you could just set your your ID, your frequency, the endingness, and we've now added a scaling and offset option. So these are new. These are really cool, so that you can scale and change the offset of your transmitted items for different dashes and stuff like that, which is unique and cool now. And then what you've now got is this multiplexed index item. So for example, I'm going to want to send, let's say, 10 layers of the 200 hex. So I'm going to set them all to 200. We're going to set the frequency of these to be something slow for the minute, 5 Hertz. Endingness doesn't matter for the minute. Scaling, it doesn't matter. Offset doesn't matter. And then what I'm going to do is set up the multiplexed index numbers. So you can see here that what it's going to do now is for the first 10 frames, this is what it's going to spit out as its multiplexed index for those identifiers. Now, it won't do that until in here you set the byte which you want to have the index. So you've got a gen TX index. When you set that, you can set that in different slots. That will basically set the multiplexed byte to be appearing in that first section of the transmit. Okay, so we've made it so that whenever you've got that in this first slot, the first byte 0, will contain the multiplexed index number. So let's just show that working. So let's program that, and let's go over and have a look at the CAN transmission. So one sec. Let's just stop these transmits here. So you can see here there's a 200 hexadecimal frame being sent extremely fast because it's being stacked in layers. So I'm going to put it into scroll mode so we can actually see what we're getting out. So you can see now that you've got the multiplexed index byte here in byte 0, which is being transmitted down on the 200 hex. And now what you can do is for each one of these multiplex things, you can put in the different values of, say, RPM, TPS in there, and then it will basically stack it down on the multiplex frame. So that is something that a lot of people have wanted to be able to receive and transmit. So we've done it in quite a nice simple way to be able to do that, and you can obviously now scale that and change the offsets on that to suit. Let's talk about the next area which we've changed in the data stream section. So you'll now see there's a triggered CAN transmit. This is quite cool. I actually really like this because it opens up lots of flexibility of what you can do in OEM applications where, for example, you are still running OEM ECUs, or you're running even with the OEM transmission ECUs and stuff like that. What you can do with this now is you can actually connect the TinyDash to, say, your OEM car, and you can use the Syvecs CAN logger program to basically pick up the CAN transmission data, which is going on, say, when you're using an OEM diagnostic tool. All of our products that have got USB and CAN on it, you can use our Syvecs CAN logger program to basically actually monitor what is going on with the CAN bus on the car and log that. And that becomes useful because if you were to use a Y splitter, you can actually split into the CAN of the OBD, use an OEM diagnostic tool, and log what kind of messages are being transmitted for different modes. So, for example, if you wanted to, say, clear the DTCs, or you wanted to put the car into, say, a dyno mode, or you want to clear the DTCs on like an ABS module. Let's say you're doing stuff like you want to disable the ABS for a bit with a switch, and it's still on a switch, and then turn it back on, and then you want to clear the errors without having to get your diagnostic tools out and stuff like that. you could basically use on, say, the TinyDash, one of the keypad pages with a touchscreen button that can be linked to that button, and then you can transmit frames. So the triggered can transmit, if you press F1, there's loads of help here, but they can be set up to basically be on any arbitrary ID or identifier. There's 8 frames available to do this. The default value is 7DF because that's the transmission ID that generally clears globally DTCs on an OEM car, and the values that we're having here for the transmit data, we'll leave that set up to basically as a DTC clear. So if you were to assign a trigger item now of, say, putting this as a button 1 on the TinyDash, when you press that button 1, the transmit frequency would just be once, and it will basically send that transmitted data there on the 7DF frame just once. And that will actually clear all the DTCs and all the modules on the car. So it means you don't have to get your diagnostic system out. You can just basically transmit that frame and it will clear DTCs. Now, if you've gone off and you've kind of looked and reverse engineered kind of the CAN frames that are needed to, say, put your car into, say, a dyno mode or a unique feature that the OEM ECU can do. Some cars you can put it into like a test mode on the all-wheel drive. Other things you can do is you can, like, say, I don't know, stop the seatbelt warnings coming on the dash by transmitting certain OEM kind of base frames in the 700 section. So you can kind of do all that kind of function now from here, and it's very useful that you could set up a calibration here that you could sell to multiple customers now that basically allows you to, say, press a button on the TinyDash and it clears the DTCs and it disarms certain features on the OEM car. So it's really unique. It doesn't then require people to go out and buy expensive diagnostic kits. So there's real flexibility of what you can do here. So all these items are blue. That means you need to program it to change it. The trigger item is where you can set the item in which you want to basically be triggering off the frame gets sent from when it's active. So what that means is when these values are greater than 0, okay, then the trigger will become true. So for example, the button, it will be greater than 0. You can have a change light. You can have it so when the engine is running, if the RPM is greater than 0. So yeah, there's loads of flexibility you can do with that. If it's in limp mode, you can then have it to send a DTC clear or something like that to on the OEM modules. Loads of stuff you can do. So yeah, hopefully that is like really useful for you. You can set up some really cool features with that, and especially with the latest TinyDash V2, which has got the touchscreen options, it opens up loads of flexibility of unique features. Okay, enjoy.